Good morning, afternoon, and evening to you all. On behalf of APITBIO, I would like to welcome you all today and thank you for taking your time to join us. I am Kim Soo-hong, or Daniel. I'm an Associate Director of Business Development here in APITBIO. I did my schooling and college education in George Washington University in District Columbia as a biotechnology major. It is my personal honor to be a presenter here as a Bio Europe Spring presenting company. And it has been about 5 years since I've joined the field, and every time I meet with colleagues or partners in the field, I always feel connected and sense that we are all here for one major common cause. We are all here to make the world a better place by treating the unmet medical needs of the patients. With that being said, let's start with challenges and unmet medical needs we are facing today in cancer therapy, especially in immuno and chemotherapeutic approaches. Firstly, there are immunotherapeutic drugs which makes up a great portion of blockbuster drugs today. Yet the overall responsive rate is only about 15 to 20% for patients globally. There can be various reasons behind it, such as T cell exhaustion and immunosuppressive tumor microenvironment. Secondly, the traditional chemotherapeutic approaches are relatively well established, but still contains the severe side effects, which only allows the global patient's responsiveness only up to 55%. To solve the aforementioned problems, we believe that rational combinations of microenvironment targeting therapy with immuno or chemotherapy will comprise the next generation of the cancer treatment. Therefore, from the establishment of our company, we have been following two major mission statements. First, to improve the tumor microenvironment with the goal of enhancing response to the immunotherapy. And secondly, to directly enhance the efficacy and survival rate by combination therapy. Let's go over to the above-mentioned mission's rationale and data now. Just to give you the bird's eye view of our company, we are a Seoul, South Korea-based biotechnology company established in December of 2018. It was established by a group of experts in the field of antibody development and CD171 or L1CAM target through various cooperation with the industries, academia, and research institutes. We have proprietary antibody library, which serves as our platform technology to generate hit discovery antibody candidates. And our leading asset, AB612, is a first-in-class monoclonal antibody targeting L1CAM or CD171 for solid tumors and rare cancers. Before going into the details of our technology, I would like to mention about the credentials we have as a company. Our key scientists have been publishing in high-profile journals such as Nature Communication, Clinical Cancer Research, and Cancer Letters, and so on. The papers were published based on not only the development and engineering of antibodies, but most of them are published based on the target L1CAM and its roles in numerous types of cancers, which indicates that we are not only experts in the antibody engineering, but has been pathfinders in the target L1CAM, which are getting worldwide attention today for its roles in cancer. Please keep in mind that all the rationales and some data in these presentations are based on these papers published. Allow me to introduce our leading asset, an L1CAM antagonizing antibody, AB612 as a first-in-class, fully human monoclonal antibody. I would firstly like to address about the roles of L1CAM or L1 cell adhesion molecule. L1CAM either binds to another L1CAM in the surface membrane by homophilic binding or other natural proteins like RTKs or integrins via heterophilic binding, which plays a crucial role in tumor proliferation, migration, and invasion in tumor upon overexpression of L1CAM. Here we have L1CAM overexpressed and knocked down on the top and bottom of the graphs respectively, and the increase in overexpressed group, tumor's total cell number, invaded and migrated tumor cell numbers were observed in the cholangiocarcinoma cell line, where the knockdown groups decreased. This is by the overexpressed L1CAM phosphorylating the FAK and AKT to advance the tumor condition. Here we had collaboration with National Hospital in Seoul comparing 3 different cancer tissues with on-site normal ones, cancer tissues being gallbladder, pancreas, and intrahepatic bowel cancer tissues. We can observe that the levels of L1CAM expressions in cancer tissues were much higher, and we have concluded that high expression of L1CAM in cancer tissues has strong correlation with solid tumors. And when it has strong correlation with solid tumors, naturally and evidently, it always has a strong correlation with a short overall survival rate of cancer patients. We have observed that L1CAM's high expressed group had much more steeper graph trend compared to the low expressed group, indicating that high L1CAM expressed group had much more lethal effect than the lower expressed group. We have also observed that the antagonizing of L1CAM extended the survival rate from 40 days to 120 days in doxorubicin treated group, and about 30 days extension of survival in irradiation treated group. Also, the cardiomyocyte radius being normalized in the irradiation treated group as well. The rationale behind it was published. Inhibition of L1CAM leads to decrease of radioresistance of glioblastomas through MBS1 upregulation and the enhancement of CHK2 signaling, which are responsible for cellular response to DNA damage and cell survival. Going into the role of L1CAM plays in the tumor microenvironment, here in pancreatic ductal epithelium, when it goes under mesenchymal transition with the moderate expression of L1CAM, it seems like it still recruits debalanced amounts of T effector cells and Treg cells. But when it achieves the mesenchymal phenotype with strong L1CAM expression, the recruitment of regulatory T cells increases while the recruitment of T effector cells decreases, meaning the high expression of L1CAM in tumor causes the tumor to have an immune escaping mechanism, favoring the generation of immunosuppressive regulatory T cells. And how this happens is that firstly, the L1CAM facilitates the CCL22 expression by activating the PI3 kinase, AKT, and NF-kappa B pathway. Then the CCL22 promotes the Treg recruitment to the tumor site through CCR4. The Treg secretes the TGF-beta. Then the TGF-beta again overexpresses the CD171 or L1CAM, making a vicious circle in the tumor microenvironment. Another role it plays is the high expression of L1CAM causes a tumor-specific angiogenesis. It builds immunosuppressive microenvironment where the PD-L1 expressions and recruitment of the T effector cells decrease, while the Treg cells increase. Thus, by antagonizing L1CAM, we can expect tumor vessel normalization, where we can open windows for chemo or immunotherapeutic agent to play its role efficiently as a combined therapy. To summarize, L1CAM plays majorly in two different roles in tumor microenvironment and tumor growth, which makes a tumor to have an immune escape mechanism and causes a short overall survival. Let's look at our data now. This will be our representative data for our company's missions, and we have utilized human PD-1 knock-in melanoma-bearing mouse models. And groups are divided into single treatment of pembrolizumab, Keytruda, AB612, and combined treatment of AB612 with Keytruda. To observe dose dependency, we have only increased the dosage of AB612 with Keytruda staying the same. As you can observe, it showed dose dependency with about twice more efficacy when they were combined. We have also done our epitope mapping, and our candidate binds to Ig-like domain 5, where it has an accessibility and sustainability for binding persistency. Also, we have confirmed our mapping by computational modeling with National University and APITBIO. We have also done the internalization study as well, which I won't go farther in this presentation, but we found that our candidate internalizes into the cytoplasm within 30 minutes. And furthermore, we have observed that they were internalized within 15 minutes, which will serve as interesting data for ADC partners of ours. Now let's talk about the synergistic effect in vitro and in vivo with the chemotherapeutic agent with AB612. And here the agents being Zemzar and cisplatin. Here you can see that AB612 combined with Zemzar showed about twice more efficacy compared to the single treated group with 20% increase in epitopic cell volume increase in cholangiocarcinoma cell line. Similar rationale with pancreas cell line, where the efficacy was twice higher with 15% increase in epitopic cell volume increase in combination therapy compared to the single treated group of Zemzar and AB612. Going into the vivo condition now, we have observed that AB417, which is the lead antibody of our candidate AB612, with Zemzar as a combined therapy showed about 88% impediment, while the single treated Zemzar and the AB417 was 44% and 35%. And on the bottom, about 80% of the tumor volume decrease, while the cistaplotin had about 50% reduction and 40% with AB417. I want to mention that the combined and the single treatment did not affect the body weight at all. Then we have firstly conducted in vivo study to find out the monotherapeutic efficacy in human PD-1 knock-in melanoma-bearing mouse models. AB612 demonstrated its tumor volume reduction effect in dose-dependent manner from inhibition rate ranging from 12.5% to 58.3%. We have also compared its monotherapeutic effect with commercialized immune checkpoint inhibitors, in this case Keytruda and Tecentriq. We observed the comparable effect in monotherapy in melanoma tumor-bearing mouse model. We are also initiating studies regarding the bispecific antibodies. We have conducted the feasibility check so far with bispecific antibody with commercialized antibodies such as pembrolizumab and nivolumab, which showed about 62% and 72% of tumor weight decrease compared to the vehicle respectively. We have completed the preliminary toxicity study, and no notable toxicities in general, cardiac, or neurotoxicities were found, with the NOAEL set with 40 mpk for SD rat and 25.2 mpk for cynomolgus monkey. In the GLP toxicity study being conducted now in Charles River, we have escalated the dosage regimen even more to find candidates' potential toxicities. We have entered into the GLP toxicity study with Charles River last year, and we have designed the dosage escalation studies as follows. We are escalating the dose up to 500 mpk for SD rats and up to 400 mpk for cynomolgus monkey. 4-week toxicity studies dosing regimens, which will take place after, will be decided upon the results of 14-day toxicity study. With our leading asset entering GLP toxicity study this year, it is expected to finish in 4th quarter this year. Then we'll be filing for an IND submission in South Korea for its first-in-human study. We are further selecting the indication along with the pancreas cancer and cholangiocarcinoma. What we're doing is that we are gathering big data from multiple hospitals to compare high expressions of mRNA of L1CAM with the poor prognosis relationship. It looks like I have some time to explain about our state-of-the-art proprietary antibody platform-based library. Out of the generations of the libraries we still utilize with synthetic libraries, CDR subfamily-based combination, which allows us to have a higher diversity, affinity, and stability. What differentiates our library is that we design our scaffold to be equally optimized for expression. We use the human antibody repertories of CDRs, which allows us to have a lower immunogenicity, faster optimization, better solubility and CMC, and higher affinity. We omit the PTM sites, post-translational modification sites, such as N-linked glycolization, deamination, isomerization, and protease cleavage. And also we have implemented the TRIM technology to have bigger library with the higher levels of QC. We're pretty flexible with pursuing various models of licensing and collaborative partnerships, from identifying the target together utilizing our library to start from concept to development, to collaborative study in combination therapy, bispecific antibodies, CAR-T and ADC. And even though we're planning on going into the first-in-human study in Korea, we're looking for clinical partners for global clinical trials as well. We are open for discussions and ideas regarding how and what to collaborate on, so please feel free to email me or send me a meeting request during the event at any time. This concludes my presentation. Thank you very much for listening, and I wish you all to have a fruitful Bio Europe spring. Thank you.